So, this is the second part of our sampling lecture. Here I will start with the types of sampling. I have this chart here. So, this tells about the kinds of sampling strategies. So, we have various kinds of sampling algorithms here. So, it is based upon the probabilistic and non-probabilistic characteristics. So, non-probabilistic here means the qualitative. These are also known as qualitative, and these are known as quantitative sampling. In quantitative or probabilistic sampling, I have simple random sampling, systematic sampling, cluster sampling and stratified sampling. In this qualitative sampling, we have judgment, convenience and quota. So, let us discuss these one by one. So, the first one is simple random sampling. A random sample is a sample selected in such a way that every possible sample with the same number of observation is equally likely to be chosen. That is, the probability of selecting each item here is equal. So, if I say, if I throw a dice, so probability of getting 1 is 1 by 6, probability of getting 2 is again 1 by 6, probability of getting 3 is 1 by 6, probability of getting 4 is 1 by 6. Similarly, all the numbers would have same probability. This is known as simple random sampling. So, what are the characteristics of this sampling? The two basic procedure here are, number one is lottery method. In lottery method, what we do? We pick the number out of a hat or a bag, just like that. Like we just roll a dice. This is a kind of a lottery. Any number could come. The second is use a table of random numbers. This one is used by researchers. This is actually the systematic way of conducting random sampling. So, this is more suitable for small populations. Suitable for small populations, for which sampling frame has to be available, and when the size of the units varies, probability is proportional to size. We call it at PPS. If the size of a unit vary, the probability is proportional to size. This is inappropriate for large population due to the lack of sampling framework. So, we have lack of sampling framework here. So, this is inappropriate here. This is a very general method, that is why it is costly, and extreme sample units are probable here. So, let me take the help of this illustration to explain how do we conduct random sampling here. Here what we have, there are 12 numbers, 1 to 12. You just pick any number, 2, number 5, number 8, number 10. We can pick any number, but that should be distributed. We just cannot pick number 1 to 4 at all. So, this is random sampling. So, next comes stratified sampling. A stratified random sample is obtained by separating the population into mutually exclusive sets or strata, then drawing simple random samples from each strata. So, what happens when the population size is large, that is when some framework is required. Actually, in this case the population size is very large, big population size. So, then we divide the population into some strata. Based on some criteria, we divide the population into segments. So, the thing is that the strata should be mutually exclusive and exhaustive as well. Mutually exclusive means they should be independent. Mutually exclusive and exhaustive. Mutually exclusive means each strata should be independent of the other strata. Mutually exhaustive means the sum of all the strata should be equal to the total population. This is mutually exclusive and exhaustive. Second characteristic here can be, it often improves the representativeness of the sample by reducing sampling error. Reduces sampling error by improving representation. Also, because the strata side could be different, so it produces a weighted mean that has less variability than arithmetic mean. That implies less variability with respect to or in comparison to arithmetic mean. Just to mention, arithmetic mean, this is used in simple random sampling. So, the variability in stratified sampling is less. So, the thing is that we select the sample in a systematic way here. We divide it into segments. Those segments are known as strata. Then we select the samples from each strata, and in the strata simple random sampling is conducted after that. This is a kind of an example here. We have a population, we have blue, red and green different elements here. So, all these blue elements form one strata, all the red elements from the second strata and all the green elements from the third strata. So, this is strata 1, strata 2 and strata 3. Then the samples are selected from each strata. Now, let me say I am talking about the number of family members in a city. So, I want to divide this into the age group: kids, adults and senior citizens. And I have found that there are 20% of the population who are kids. Kids means they might be less than 18 years of age. There are 45% adults, then 35% senior citizens. So, what stratified sampling says, we select 20% of sample from kids. If this is the behavior or characteristic of our capital N, the small n would also be kids, adults and senior citizens in the same way. So, we get a weighted mean here. This is stratified sampling. So, in stratified sampling, the cost of sampling can also be given, like the cost of sampling is C naught plus summation cost of each strata, this is CH and H, where C naught is fixed cost and CH is the cost per unit Hth stratum. So, let us see the pros and cons of the stratified sampling. So, the benefits or the advantages of stratified sampling is that it focuses on the important subpopulation. And ignores irrelevant one. In that case, this thing would not hold good. For example, if we are focusing on adults more, we will give more weight to adults here. So, it improves the efficiency of estimation. Then estimation with desired precision from the selected strata is carried out. Sampling equal numbers from strata varying widely in size may be used to equate the statistical power of test of differences between the strata. So, these benefits are there. There are certain cons as well, certain limitations or disadvantages. Those are, it can be difficult to select relevant stratification variables. Difficult to select variables. Sometimes it is difficult to select relevant stratification variables. So, it is not useful when there are no homogeneous subgroups. Homogeneous subgroups is the requirement here. So, it can be expensive sometimes. So, it requires accurate information about the population or it can induce bias. If info about population is not accurate. So, next comes systematic sampling. Systematic sampling is a modification of random sampling only. The samples are selected at the specific interval here. So, to arrive at systematic sample, we simply calculate the desired sampling fraction. For instance, if I say out of the 20 cars, that is the population size is 20, and we are interested in finding some manufacturing defect, some particular manufacturing defect in the cars, and our budget suggests to select only 2 cars. So, what we do, we divide this population 20, that is capital N by small n, 20 by 2 is equal to 10th car. So, after each 10th number, the numbers are from 1 to, if the cars are in a nominal scale, the numbers from 1 to 20 are there, we select each 10th car, this first car, second car. If this number is 200 and we need to select 20 cars, then this ratio will again be 200 by 20, that is 10th car. We will select 10th, 20th, 30th, 40th, and so on up to 200th element here. This is generally carried out in warehouses where the products which are put in, they are stacked. So, we say okay, just pick each 5th packet here. So, if 5th packet is picked here, sometimes this ratio is not taken, and based upon the past experience 5th or 10th or 16th, maybe these kinds of packets are taken for the testing. So, what happens here is in this case, this is a example here, they are picking each third element or every third element here. After 2 plus 3 is 5 plus 3 is 8, 8 plus 3 is 11th. The thing is that from where to start, he has started from number 2. This is also a criteria here. There is a way to do that, to select the seed here is one thing that we will see how to select the seed of the random numbers. So, next is cluster sampling. In cluster sampling, we have the entire population that is divided into clusters. This involves dividing the entire population into clusters, each representing the universe. Each cluster in itself is a universe. Selection of one or more clusters randomly or otherwise. So, commonly used by treating contiguous geographical areas as clusters. This reduces cost and time of sampling. What we do, I will take the same example. If I am interested in the number of students who are interested to take engineering as their career option, so I select only one cluster, one institute, one school that is teaching non-medical, or I divide it into demographic areas. I select school 1, school 3, school 8, so on, any cluster I could pick. So, this each cluster is a kind of a population itself. So, this is an example here. These are the clusters. We have 1, 2, 3, 4, 5 and 6 clusters. The sample total 15. Out of these 6 clusters, 2 clusters are selected. That is the cluster 1, this one is selected, and the cluster number 4 is selected. So, this is my sample size. Total 6 elements in the sample and 2 clusters are here. Next comes the qualitative sampling. Qualitative or non-probabilistic. So, first one is quota sampling. So, it is the part of non-probability sampling. In this method, a definite quota is fixed for different subgroups in the population, which reflects the proportion of the subgroups in the entire population. So, it requires a good understanding of the population composition, a good and detailed understanding of population. It is comparable to stratified random sampling with proportionate representation, but the thing is that this is not probabilistic. So, let us take an example here. So, these are the age groups 11 to 21 years, 22 to 31 years, 32 to 41 years and 42 to 51 years. So, the numbers here are 11 from 11 to 21 years 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, this is the quota that is fixed to this specific age group. So, sometimes this is also the convenience sampling is also associated with quota sampling. So, if we are interested more in the specific subgroup, specific age group here, we can fix that quota here. So, in quota sampling, the benefits are it is less costly. A quota interview on average costs only half or third as much of a random interview. So, it is about 1/2 or 1/3 of simple random sampling cost. This is a general statement, but we must remember that precision is lost here. I will put the cons here as well. Precision is lost. It is easy administratively. So, easy administration. The labor of random selection is avoided, and so the headache of non-contact or callbacks, all those things are avoided here. So, administration or conducting the study is easy here. So, if the field work has to be done quickly, perhaps to reduce memory errors, quota sampling may be the only possibility. So, this is quick. Perhaps to reduce the memory errors, this is done quickly to obtain immediate public reaction. So, this is also independent of the existence of sampling frame. So, few limitations here could be the precision is lost, it is not possible to estimate sampling errors, because of the absence of randomness, the sampling errors cannot be calculated here, cannot be estimated. So, the interview may fail to secure a representative sample of respondents in quota sampling, because this is just a kind of a qualitative and convenience sampling. So, the respondent may not give the representatives information for the whole population here. Social class leave a lot of interviewers judgment. So, social class, sometimes the interviewer is biased with specific social class, that becomes a matter here. So, strict control of field work is more difficult. That is, if one has done interviews, placed respondents in groups where cases are needed, then rather than in those which they belong. So, next is multi-stage sampling. So, it can be a complex form of cluster sampling only. form of cluster sampling because it is a type of sampling which involves dividing the population into groups again. It divide the population into groups. After that, one or more clusters are chosen at random, then each item in the cluster is used as the sample item. So, in this I will put it here, one or more groups are selected, then each member of group is sampled. So, this is one example of multi-stage sampling. This round represent the clusters. So, these are the clusters 1, 5, 9, this is one cluster. This is stratum. So, this is one stratum, second stratum, third stratum and fourth stratum, and the star is the item. So, what we do in the first stage, the clusters are taken here 1, 5, 9, 1 is one cluster here, this is a complete cluster. It has, so say number 1 has 20 items, number 5 might have 30 items and number 9 might have 25 items and so on. Number 2 might have 5 items. So, these are specific items in them. So, these clusters are divided into strata. Oh, this is stratum 1, stratum 2, stratum 3, stratum 4, and out of these stratum the cluster is picked up. The cluster 1 is picked up, cluster 9 is picked up, and out of 1 2 items are taken, out of 9 2 items are taken. From each clusters 2 items are taken, 2 items per cluster. So, this is known as multi-stage sampling. We can also do this mathematically, or we can give the specific weight here based on the size of the cluster. Then we can select the clusters from there and then select the number of items per cluster. Then I would like to give certain sampling tips depending upon the characteristic of the item and the kind of sampling technique that should be used here. So, number 1, if item is widespread throughout the region, then what we do, a general sampling with low sampling ratio. Number 2, if the item is widespread throughout the region and the frequency is low, in this case the frequency is high, this is the frequency of occurring. Second case is if the item is widespread throughout the region and the frequency of occurrence is low. So, here also we conduct a general sampling but what do you think? should it be a low or high sampling ratio? So, because the frequency is low, the number of items that should be taken should be high. So, in this case a general sampling with high or large sampling ratio is conducted. Third case, the occurring is with reasonable frequency in most parts. In most parts of the population, but with more sporadic distribution. So, here the word sporadic means that it is absent in some part and concentrated in some other part. That is, the distribution is not even. So, you can very well judge here which sampling should we do here. It is sporadic distribution, the frequency is less in some of the parts, frequency is high in some of the parts. So, we will do stratified sampling here. So, stratified sample, more clearly I can say with different intensities. Based on their frequency. Their frequency is the frequency of the strata here. So, next is, if distribution is very sporadic or concentrated in a small part of the region, if of items is so what happens if the distribution of items is very sporadic or it is concentrated in a small part of the region? So, this is not suitable for a general survey. So, this requires a geared sampling distribution. So, actually what we do here, we try to fit a distribution here, fit a probability distribution. So, we try to fit a probability distribution here and see which one is the closest fit and use that as our sampling strategy. So, next is design effect. Design effect is the ratio of the variance of the design used in the study to the estimated in the simple random sampling. For instance, I have used quota sampling, or I have used stratified sampling, or maybe multi-stage sampling. So, what is the error with respect to the error in simple random sampling, that is known as design effect. So, this is the ratio of variance for design, variance of design to that of simple variance of simple random sampling. This is known as design effect. So, design effect of if 2 implies the variance is 2 times as it would be if the simple random sampling method was used. I can put here design effect or is equal to 2 implies simple random sampling. It is n for simple random sampling would be half of the n for the design chosen. So, what is desired here is design effect should be less than 1. If design effect is less than 1, then only this design should be used for the study. If design effect is more, then simple random sampling is the best option here obviously. So, sample size can be said as design effect. This is of the complex design. This times the sample size for simple random sampling. So, this is design effect. So, next I have is a task for the students. Try to observe a population around you. So, try to observe maybe your family members, and a few neighbors. If you are in your hostel, this family member could be your friend group, close friend group, and maybe friends of your friends, second group. And select a product that they would like to use. You can select some pen, would they like to use that pen or not, or you can select some food item that they would like to eat. First thing is, I would like you to conduct a small survey with 3 or 4 or maybe max 10 questions that what is their reaction for selecting or using this pen. Questions you can design, questionnaire you can design, that is discussed by Dr. Deepu Philip. So, select a food item, first divide or first use simple random sampling. You pick anyone from your house, from your family, 1 or 2 samples, 1 or 2 items or 1 or 2 members, 1 or 2 from your neighbors and 1 or 2 from the other neighbors, pick randomly and then conduct the survey. Then you conduct a stratified sampling based upon the number of members. If you have 6 members in your family, you select 2 out of that, or out of 6, if I say, if I keep the sampling ratio as 50%, a big sampling ratio here, out of 6, if you select 3 out of the 4 members, you can select 2, that is 3 out of 6 or 2 out of 4. This ratio is always 1/2. Next, you try to do this using a quota sampling. Quota sampling is you give your family specific quota or your friend group a specific quota. Okay, 4 members or 4 persons from my friend group would be the part of the sample. So, try to conduct in that way, or then you can do the cluster sampling. To select your whole family group as one of this cluster, or one of the neighbors family as one of the cluster. Try to do this and see the difference. So, this practice, this exercise would help you to learn how do you select this sample, how do you select the sampling technique, just an kind of a broad practical experience into this. So, we will meet in the next lecture. So, this was all about sampling. Next, I will also give you R codes or tell you how do we select the random numbers and conduct these sampling distributions there in R. Thank you.